Everybody, and welcome to Ricky's Math Minute. It is another week, which means another math video. We're going to go ahead and get started here, continuing our series of 16 must-know ACT math questions, math formulas, and how to use them. So today we're going to look at specifically a few formulas that will relate to intermediate algebra or your upper level algebra in relation to graphing. Now, of course, if you don't need any of these or you're struggling with something different that is math related, you can always send a request and I'll be happy to make you a video. So let's go ahead and get started. First and foremost, let's look at the three formulas that we're going to dive into today, and that's going to be the distance formula, which is d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. We're going to look at the slope formula, which is m equals y2 minus y1 divided by x2 minus x1, where m is your slope. Slope-intercept form, which is y equals mx plus b. M and b are your slope and y-intercept respectively. Remember, an intercept is where it crosses the axis, so b is where your line crosses the y-axis. And then our midpoint formula, the middle of the lines we'll be dealing with x1 plus x2 over 2 and y1 plus y2 over 2. And we'll be using these to look at a few examples, beginning with our distance formula. So we're going to start by letting W and Z be the points of intersection between the parabola whose graph is y equals negative x squared minus 2x plus 3, and the line whose equation is y equals x minus 7. What is the length of the line segment WZ? So we know we're dealing with the length of a line segment. Anytime you hear length of a line segment, you should automatically think I'm dealing with distance formula, which is why I've written that there. And then also, maybe you're sitting there watching this video and you're like, well, I have zero idea what a parabola is. Well, that's okay. You don't have to know what a parabola is to approach these problems. What you do need to know is that both of these are equal to one thing. They are both equal to y. So since they're both equal to y, we can set them equal to one another. And that's how we're going to start this problem. So negative x squared minus 2x plus 3 equals x minus 7. Now, we need to get all of our like terms combined and get one of our sides equal to 0. Now, something I don't like to do is have a leading coefficient being negative. So I'm just going to go ahead and multiply everything on this side. Instead of multiplying, let's divide. I'm going to go ahead and divide everything on this side by -1. And what I do to one side, I have to do to the other. So we're going to divide everything by -1. That's going to give me x squared plus 2x minus 3 equals negative x plus 7. Now I don't have a leading coefficient on the left-hand side that's negative. So now let's start getting the right-hand side to become 0. Well, to do that, we're going to add x to both sides. And that's going to zero out my x's, so that's going to be x squared plus 3x minus 3 equals what's left on this side, which is 7. A little bit closer, let's get that 7 to become 0. How do we get positive 7 to become 0? Well, we subtract 7. I'm going to do that to both sides. That is now 0. X squared plus 3x minus 10 is now what we're dealing with. This is a perfectly factorable expression. This is a perfectly factorable and solvable equation. What we need is we need to find our x values because we know distance formula deals with 2 coordinates, but we don't have any coordinates yet. We don't have any ordered pairs, so we need to find some x values, okay? So let's do that. I'm thinking about my factors of 10, Okay, in order to create a binomial here, I need to get my factors of 10, and I know one of them has to be negative since my 10 is negative, because a negative times a positive will be negative. So what two factors can somehow become 3, a positive 3? Think of your factors of 10, 1 and 10, and 2 and 5. Well, 2 and 5 I can do something with. How can I make this a positive 3? Well, if I have the larger number being 5, positive, and a negative 2, now we're dealing with something here. And then we bring our x's because we need x squared. All of this is still equal to 0. Well, like you saw in last week's video, now we just solve for x to get our roots. When we do that, we get x values of negative 5 and positive 2. Okay. Well, I like this expression here, this equation, because it's a little bit easier. I need my y values. So y equals x minus 7. Let's find my y value for negative 5 first. So y equals negative 5 minus 7. Y equals negative 12 when x is negative 5. So my point W is going to be negative 5, negative 12. Okay. And then let's do that again for our other x value, which is a positive 2. So y equals 2 minus 7. When x is 2, y is negative 5. So my point z is going to be 2, negative 5. And now I have the two endpoints of this line segment, and I'm able to go to work. So let's deal with our distance formula now. It's important. Let's label x1, y1, x2, y2. Could you have labeled 2 as x1 and negative 5 as x2? Yeah. Doesn't matter as long as you're consistent. So we're using, again, this formula. x1 minus x2 squared plus y1 minus y2 squared. This is going to be negative 7 squared plus negative 7 squared because change. Negative 12 plus 5 is going to be 7. 49 plus 49 was the square root of 98. Now, a square root of 98, by taking the square root of that, you're going to get a non-repeating decimal, a crazy number. But I do know some factors of that. So if we were to do, like out here to the side, like a factor tree, well, we know 49 times 2 is 98. 7 times 7 is 49. So we're dealing with square root. We can pull out 2 squares. So it'd be 7 square root of 2 is your answer here. Now, the reason I wrote it this way instead of writing a decimal, because the next one's going to be a decimal, is because the 4 choices the ACT gave you for this question were not in decimal form. They were in simplified square root form. So that's why I did it this way. Okay. The next y-plane, what is the length of a line connecting points at -2, -3, and 5, 6? Well, again, we're dealing with length of a line, so we know we need distance formula. Okay, so let's write our distance formula out. This one is much more straightforward. A little bit easier to deal with. Let's go ahead, just for continuity purposes, and label this. Okay, boom. All we have to do now is substitute these numbers and simplify our square root. I'll tell you in this one, the ACT did give you decimal answers and says use a decimal approximation, rounded to the nearest tenth. So we're going to do that this time. 2 minus 5, okay, and then -3, 6. Again, I got those numbers directly from my coordinate pairs. We're dealing with -7 squared plus -9 squared. You are always going to end up with positive numbers here, so 49 plus 81. And that's going to give you square root of 130. It wants decimal approximation, so at this point you would just type this into your calculator. Square root of 130, you would get approximately 11.4, which would be your answer. Obviously, as you can see here, when you're given both of the endpoints, it's a far simpler process than something like this. But again, both of these are questions that you could see on the ACT, so knowing how to approach them is going to be super important to improve your math score. Okay? Perfect. Now we transition to dealing with slope. Well, anytime you see slope and you're given 1, 2 coordinate pairs, I know I'm finding slope from 2 coordinates, which is going to be m equals y2 minus y1 over x2 minus x1. Okay. Again, for continuity purposes, you're going to label your coordinates, but your ones have to be together and your twos have to be together. So I can't label this x1 and y2. That doesn't work, right? What does, though, is x1 and y1 have to both be in the same coordinate. X2 and y2 have to both be in the same coordinate. So now all we do is we substitute in our values. 12 minus 7 over 4 minus 3. You get 5 over 1. Well, anything divided by 1 is just itself. And you now have slope equals 5. And that is the exact way to approach that problem. There's no other way to think about it, no different way. When you're given 2 coordinate pairs, this is how you do it. And it's straightforward. But again, what makes this straightforward? What makes this an easy problem to approach? The only thing that does is knowing that formula. You have to know and memorize in some way these formulas to be able to recall on a question like this. This one is asking for the slope of this equation. Well, anytime you're given an equation, I want you to think of slope-intercept form. Slope-intercept form is always a positive y equals mx plus b. Well, to find m, it has to be in that form. Well, all this is then is a manipulation of the equation. You're just moving it around to make it work for you. So how do we get y by itself? We need to add 16x to both sides. Now we have 6y equals 16x plus 7. I just used commutative property there to rearrange that. But my equation here shows a coefficient of 1. Right now I have a coefficient of 6. So what's happening between 6 and y? 6 times y. I need to get rid of 6, so I undo that operation by doing the inverse operation. The inverse of multiplication is division. So I'm going to divide by 6 and divide by 6. Now I'm going to end up with y equals y equals 8/3x plus 7/6. And how did I get 8/3? Well, in one step, I just went ahead and simplified that. I knew that 2 would go into 16 and 6, so I simplified. Now, it asked what the slope was. Slope is 8/3. Now, you can go a step further, depending on what your teacher wants, and depending on what the ACT asks for. In this case, an improper fraction was the case, but you could get 2 2/3, right? If you were to convert to a mixed number. 9 times out of 10, when you're dealing with high school math, you're going to keep it in this first improper form. And one more like this. Again, we need y equals mx plus b. You are going to have 4x 16y equals 24. So I'm going to subtract 4x from both sides. I'm left with negative 16y equals negative 4x plus 24. I need a positive y. So I'm going to divide by negative 16 and divide by negative 16. So that's going to leave me y 4/16x plus minus 24/16. Why? Well, a negative divided by a negative becomes a positive. So that's how you have this positive 4/16 here. And then a positive divided by a negative will become negative. So that's why I changed that to a subtraction. But we do need to simplify this. And that's going to be 1/4 x. And this is going to be 3/2. Again, I'm just finding the largest number that can divide into both of them without creating a decimal. 4/16, the largest number is 4. 24/16, the largest number is 8. So here, the slope of your line is 1/4. Okay. In the standard XY coordinate plane, the midpoint of line XY is 12, -3, and point X is located at 3, 4. What are the coordinates of point Y? Okay, we're given our first point, and we're given the midpoint. Well, anytime you hear midpoint, I want you to think of your midpoint formula. And to not confuse you, I'm going to write mid. My midpoint formula says x1 plus x2 divided by 2, y1 plus y2 divided by 2. Other than like a guess and check process here, I'm not given enough information to know what coordinates of point Y are. But with a little bit of work, I can figure it out. The midpoint is 12, -3. Well, that's this, right? This is midpoint. So I can write 12, -3 here. I also am given one coordinate. So let's say that this is x1 and y1. Let's go ahead and write 3 plus x2 over 2 and 4 plus y over 2. You don't have to write this subscript 2 here. Okay. Okay. Now I'm dealing with something. Well, how do I set this equal to anything? It's a coordinate pair. Well, your x's are going to deal with your x, and your y's are going to deal with your y's. So 3 plus x over 2 is going to be set equal to 12 because this is x, this is y. 4 plus y over 2 is going to be set equal to -3. Now you can solve, and what we're doing is we're finding point y. So multiply both sides by 2 here to get rid of that. So then you're left with 3 plus x equals 24. Now you have a one-step equation. -3. And x is going to equal 21. Same thing here. Multiply both sides by 2. 4 plus y equals -6. How do we get y by itself? Subtract 4. Y equals -10. I now have an x, I have a y. That means point y is going to be 21, -10. And just like that, no guessing and checking, no figuring anything out. You knew the formula, you plugged in the numbers, you substituted them, and you ended up with point Y. Good work. And we have one more. And it's midpoint. Okay. So the midpoint of a line segment is 4, -1. If one endpoint of the line segment is -4, 3, what is the other endpoint? So we're going to approach this the same way as we did before. Midpoint equals x1 plus x2. And that's over 2. And then y1 plus y2 over 2. All right, so this is midpoint. And this is, we're going to plug in, like I said, x1, y1. So it's going to be -4 plus x over 2 and 3 plus y over 2. We split these apart. -4 plus x over 2 equals 4. And 3 plus y over 2 equals -1. Multiply both sides by 2. X is going to equal 12. We add 4. Multiply both sides by 2. All right, so your endpoint, you've now found it. 12, -5. And that is how you'd approach midpoint problems, slope problems, and distance formula related math problems. Of course, next week we will begin looking at a few geometry related problems as it pertains to those 16 ACT questions. Do you need to request a video? Leave a comment below. Reach out to me. I'm happy to help in any way that I can. I hope you're enjoying a little bit more of an unconventional approach to learning math and the tutoring that's taking place. If you have any questions, reach out. I look forward to hearing from you.